Here we are on page 8 of lines. An air traffic controller examines 4 flight routes represented by straight lines given in A through D below. So the first one is given in point gradient form. So remember, there's a couple ways to do this one. The first way is without the calculator. You could look and see that this is the y coordinate of one of the points. This minus -4. -4 would be the x coordinate of one of the points. So you could graph -4 and -1, and then you could graph the slope. Okay. The other thing you could do is you could rearrange it so that you can put it in the calculator. So I would subtract 1 to the other side. So I would have y equals -1 times x plus 4. And then I would add 1 to this side. And I could put that in the calculator. And then it would be ready to graph. So I could have -1 times x plus 4. X plus 4. And then plus 1. And then I could look at the table and get a couple points. So, oh my gosh, they're all negative. Okay, so one of the things we're going to do is we're going to draw the graphs of the 4 lines on the same pair of axes. I unfortunately did not give you much negatives, much space to graph these. So let me try to graph it as best as I can here with the little space that there is. Let's see, one of the points would be -3, 0. So let's graph that, -3, 0. So that would be that one there. And then -2, 1 would be this point here. And that's pretty much it, right? Otherwise, it's going to go off the edge of the thing. I'm sorry about that. I didn't make the grid in the right place. Okay, so I graphed that. Then the other thing that I want to do with this line is to determine the x and the y intercepts of the route. Oh, for route A. Okay. I guess let's graph them all first. Okay, so graph of B. We'll do it in green. The way we'll do that is we will say y equals 0.5x plus 3. Oops. Okay, and then we'll look at the table. And like 0, 3 is one of the points. 2, 4 is another point. So we can already see that it's going to be about like that. Okay, that's green. And then last of all, let's do this one. Now, if we put y by itself on the left side, then we can put it in the calculator. So it would be y equals, and then we'll subtract 2x from both sides. And we'll add 5 to both sides, and we'll get -2x plus 5. So let's type that in, -2x plus 5. And then we'll look at the table. And 0, 5 is one of the points. And 1, 3 is one of the points. And 2, 1 is one of the points. Okay? All right. So these are all planes flying on a map, right? Okay. And then, oh wait, one last one. Line D is a line with gradient of 2 passing through -1, 3. So let's do that with the highlighter. Gradient 2 and passing through -1, 3. I'm going to just use a narrower highlighter size. So I'll do like smaller, okay? So it'll be, goes through the point -1, 3, which is here, and then it's going to have slope gradient of 2. So that means over 1 and up 2. Over 1, up 2. Right? Okay, so that is line D, yellow. Okay, we drew the graphs of the 4 lines. Part B, determine the x and y intercepts of route A. And route A is the red one, right? So it's kind of hard to see because it goes off the edge of my map, but it looks like one of them's about here. That would be the x-intercept, and this would be the y-intercept. Let's find out what it is by putting it in the calculator, okay? So I'm going to put the red one back in the calculator. If you left it in, then great. You don't need to type it in again. Okay, and then I'm going to look at the table, and then I'm going to see, and I think it's better to look at the graph. Let's look at the graph, and then we're going to find the x and y intercepts. Do you remember that from a couple pages ago? To find the y-intercept, we just press trace 0. Enter. And we find out that the y-intercept is -3. So the y-intercept is -3. How do we find the x-intercept? We're going to do second calc 0, and we're going to see where it crosses the x-intercept. And we move the cursor slightly to the left of the x-intercept, which looks like it's about at -3. I'm gonna put in like -5. Oops. I think it doesn't like when I press negative. So let's see. Graph again. Second calc 0. Okay, and then I'm going to move the cursor to the left by pressing repeatedly on this button. This is very slow. Okay, once I get to the left of the crossing point, then I can hit enter. Not there yet. Not there yet. Not there yet. Okay, now I think I'm there. So I hit enter, and then I move it slightly to the right of the crossing point. And then I hit enter again, and then I hit enter for guess, and my x-axis intercept is -3, right? So they both are -3. Interesting. Okay, and then they want to know the intersection point of routes A and B. So A and B would be red and green. So red and green, that would be the intersection point about there. Let's now graph the green line, which would be y equals 0.5x plus 3. Y equals 0.5x plus 3. Graph. And then I want to find the intersection point of the two. So I go second calc intersect, which we did in our investigation. You can see it's number 5. And basically I hit enter 3 times. So first curve, second curve, guess. And the intersection is -4, 1. -4, -1. Hopefully the -4, 1. Hopefully the planes don't arrive at that point at the exact same time. That would be a collision, right? Part C. Show that the routes C and D have the same y-intercept. Okay, so let's put in from the graph, we can already kind of see that, right? The yellow and the blue seem to have the same y-intercept. We could demonstrate it with these lines here, or we could graph it on the calculator and find out their intersection point is the y-intercept. Okay, so we already have -2x plus 5 in the calculator. We don't. Okay, so let's put both of them in the calculator, and then we'll show that the intersection point is the y-intercept. Okay, so C would be -2x plus 5, -2x plus 5. And then D would be a line with gradient of 2 passing through -1, 3. So what form is convenient to write that in? It would be point gradient form, because they gave us the gradient and they gave us a point. So we would write that as, I'm going to let's see, I'll try to like write this in yellow. So I'll do a pen, and I don't know if this is going to look good. Let's do black, okay? So we'll do black pen, and I'll put, let's see, y minus 3 equals 2 times x minus negative 1, which is x plus 1, okay? And then I'm going to arrange that so that I can put in the calculator, so I add 3 to both sides. So I'll have 2 times x plus 1 plus 3. Okay, and then I'll put that in the calculator. So it'd be 2x minus, or x plus 1, and then I put plus 3. And I'm going to graph the two, and they're going to intersect on top of the y-axis. So we could find the intersection by doing second calc intersect, or we could use trace 0, right? So let's do trace 0 for blue, and then we'll do trace 0 for red, and then we'll show that both of them have the same y-intersect, okay? So to make it simpler, I'm going to go here to the equal sign. I'm going to toggle off the red. So do you see I clicked on top of the equal sign, and now the red is off. And now when I graph, it only shows me the blue. And then I'll do trace 0 to see the y-intercept. Oops. Graph. Trace 0, enter. And the y-intercept is 5. Okay, now let's look at the red line. So I'm going to toggle the red line off, and I'll toggle the blue line. I'm going to put the red line on, and I'm going to make the blue line off. And then I'm going to graph it, and then I'm going to trace 0 again to see what the y-intercept is for this one. Trace 0. And it's also 5. Okay, so both of them have a y-intercept of 5. Okay, all right. Now let's go down here where we start talking about perpendicular lines and their gradients. So remember in the investigation that perpendicular gradients are negative reciprocals of each other. Okay? Basically, that's what it's saying here, except it's in a very maybe hard to understand mathematical formula, but that's what they mean. Okay? All right, let's look down at number 1. Find the gradient of a line which is parallel to each line with the given equation. Okay, so now with the ones in gradient intercept form like this one, a little bit easier because remember, if you look at it, the number that is being multiplied times x is the gradient. And it looks like there's a negative sign for the x. That's actually the same as multiplying by negative 1. So the gradient is negative 1. Okay, so let's write negative 1 for that one. What about b? X equals 7. Now we know that that form of line is either a vertical line or a horizontal line. And if you remember, it's counterintuitive. So when you see the x there, you think, oh, it's parallel to the x-axis. Actually, it's parallel to the y-axis, which means it's a vertical line. Okay, so a vertical line has a really, really big slope. In fact, the slope, you could say, is undefined or infinite because it's so big. Okay, part C. Okay, now for this case, it's hard to see what the slope is because it's in kind of a weird form here. If we arrange it into gradient intercept form, a little bit easier. So let's put the y by itself on one side. So we can first we'll add x to both sides, so we'll get, or subtract x from both sides, so we'll get this, right? Negative 3y stays on the left. Subtract x from both sides, we get minus x plus 5. Then we're going to divide both sides by negative 3, and then we'll get y equals negative x divided by negative 3, and plus 5 divided by negative 3, okay? And so basically, if we simplified that, it will be y equals x divided by 3 minus 5/3. Okay? And once you get to this point, it's a little bit tricky because then you're like, well, what is the number being multiplied times x? There is no number being multiplied times x. It's dividing by 3, okay? But you got to remember, dividing by 3 is the same thing as multiplying by 1/3, right? So the slope here is going to be 1/3. All right? Okay. And what about for d? D happens to be in, it looks like it's halfway in between gradient-intercept form and point gradient form, right? You're like, ooh, this would be point gradient form, except for there's no number being subtracted from y, and there is a number being subtracted. It's 0, right? So this is actually, could be considered gradient-intercept form. So what does this indicate? It's the gradient. So the gradient in this case is -2/5. It's right there, right? Okay, so if you see it in gradient-intercept form or in point gradient form like this one here, you just pick it out because it's being multiplied right in front of the x. Okay, and then if it's not, then you try to rearrange it so that it's in gradient-intercept form. Okay, what about number 2? So those were gradients that are parallel to each of the lines. Number 2 says, find the gradient of a line which is perpendicular to each of the lines. Okay, so for the first one here, the gradient is -3 because it's if in gradient-intercept form, -3 would be the gradient. And what would be the perpendicular of -3? It would be -1 over -3, which is equal to +1/3, right? What about B? So B, let's see, it's not in gradient-intercept form or point gradient form, so we can't pick out the gradient very easily. So let's rearrange it so that y is on the left side and everything else is on the right side. We have x over 4 on the right side, and we have 2y on the left side. Now, how do we get y completely by itself? We divide both sides by 2, so we get y equals x divided by 4 divided by 2, which would be x divided by 8. And remember, divided by 8 is the same thing as multiplying times 1/8. So the slope here, the gradient here, is 1/8. So the perpendicular would be -1 over 1/8. And if you put that in your calculator, you will find out it's actually equal to -8. Let's test that out. So I'm going to open up my calculator, and I'm going to put -1 divided by 1 divided by 8. And it gives me -8. Okay? All right. What about C? C is y equals -3. Y equals -3. Is that a horizontal line or a vertical line? Remember, x equals 7 was a vertical line. Y equals -3 is a horizontal line because the y coordinate, which is the height, is always the same. It's always -3. So that means it's a horizontal line, and the horizontal line has a slope of 0, right? Okay, now what is the perpendicular to 0? The perpendicular to 0 would be -1 over 0. It would be infinity, okay? So infinity is the perpendicular gradient from 0, all right? All right, and last of all, D. So now we have y equals 2 times x minus 1 divided by 3. So if we rearrange this a little bit, we can see that this is actually in point gradient form. Y equals 2/3 x minus 1, right? So why isn't there something being subtracted from y? There is. It's 0. So y minus 0 equals 2/3 times x minus 1. So our gradient is 2/3. What is the perpendicular to 2/3? It would be -1 over 2/3. Okay? Which is actually -3/2, but let's do it in the calculator. -1 divided by 2/3, which is -1.5. Okay, and that's it for this page.